Hi guys, we're moving on in chapter D for D3, and today we're going to be looking at proportions. And a proportion is an equation stating that the values of two ratios are equivalent. So we're going to take a look at our first example. Tell whether the ratios form a proportion. And so we've got 6:4 and 8:12. So we're going to see if they're equivalent, and if they do, that means that they would be a proportion. So what I'm going to do is I'm going to take my 6:4 and I'm going to put it into fraction form. And then I'm going to go ahead and simplify that down into simplest terms so I can see I can divide them both by 2, and that gives me 3 halves. And then I'm going to do the same thing with my 8:12. I will do 8 twelfths. I can divide both of those by 4. And when I divide both of those by 4, I get 2/3. So I can't put 6 to 4. It is not equal to 8 to 12 because they're simplified fractions of 3 halves and 2/3. Those aren't equal to each other, so they do not form a proportion. If I take a look at our next example, 10 to 40 and 2.5 to 10, I'm going to do the same thing. I'm going to go ahead and I'm going to put my 10 to 40, and I'm going to simplify that down, divide by 10, divide by 10, and I get 1/4. Then I'm going to go ahead and I'm going to take my 2.5, oh, that decimal didn't look very good, 2.5 to 10, and in this fraction we have a decimal, so I'm going to get rid of that, and the way I get rid of that is by getting that decimal moved behind the 5, which means since our number system is based off 10, I'd have to times it by 10, so I'm going to do that to both my numerator and my denominator, and that gives me 25 over 100. And now I can simplify this fraction. It doesn't have a decimal in it anymore. I can simplify this fraction. I can divide by 25, divide by 25, and I get 1/4. And since I have 1/4 and 1/4, I know that 10 to 40 is a proportion, is equal to 2.5 to 10. So they form a proportion because they are equivalent. All right, that's one way that you can see if ratios are proportional. Another way is using cross products, and I think you guys are really going to like this way. So what you do, once again, I'm going to take these ratios and put them into fraction form. I'm going to take my 6 to 9 and make it 6/9, and I'm going to take my 12 to 18, and I am going to make it 12/18. And to do cross products to see if they are equal and they are a proportion, you go diagonally and you multiply. So I would do 6 times 18, and I come over here, 18 times 6, 6 times 8 is 48, and 6 times 1 plus 4 equals 108. And then I would do my other diagonal, and I would do 9 times 12, which is one of my basic facts, and that's 108. So since when I did the cross products, they both came out to 108, I know that 6 to 9 is equal, it is a proportion to 12 to 18. All right, our next example, I'm going to do the same thing. I'm going to do cross products again. I'm going to change my 2 to 3 to 2/3, and my 4 to 5 is 4/5. And I'll go ahead and do this diagonal. 2 times 5 is 10. And 3 times 4 is 12. So their cross products are not equal. Therefore, I know that 2 to 3 is not equal, not a proportion, to 4 to 5. So that's another way to see if they are proportional. Our next example, it says two quantities are proportional when all of the ratios relating the quantities are equivalent. These quantities are said to be in a proportional relationship. Okay, so what they're having us do is we are going to be looking at the ratio of x to y. There we go. So we're going to look at each one of these ratios right here to see if they all are proportional to each other. So our first ratio that we have is 1/2 to 3. And in order for me to simplify this, since the numerator has a fraction in it, I'm going to change this to a division problem because we know every fraction is a division problem. So I've got my 1/2 divided by 3, which really means 1/2. Take your same change flip, 1/2 times 1/3, which equals 1/6. And you can see that right there. And then when we look at this second one right here, it already is 1 to 6. So that already is 1/6. Our next one that we're going to look at, the third row, is 3 to 2, or 3 halves to 9. There we go. And once again, we are going to go ahead, and since we have a fraction in the numerator, we're going to change it to a division problem of 3 halves divided by 9, which really means when we do our same change flip, we're going to do 3 halves times our 1/9, and I can cross cancel. I'm going to make this a 1, make this a 3, and we end up with 1/6. You can see that right there. And then our last one right here, we have 2 to 12. So if I just take by 2 to 12 and I divide by 2, it comes down to 1/6, which you can see right here. So if we take a look at each of those ratios of x to y, they all simplify down to 1/6. So these quantities are proportional. All right, we have one more example modeling real life. It says you swim for 16 minutes and complete 20 laps. You swim your first 4 laps in 2.4 minutes. How long does it take you to swim 10 laps? All right, so we're looking at minutes and laps here. So our first ratio that they give us is it takes 16 minutes for 20 laps. And then they tell us that in your first 4 laps, you take 2.4 minutes and swim 4 laps. All right, so what we are going to do with this is we are going to take this down to the unit rate. So in order to do that, you're going to take your 16 minutes and you're going to divide that by the 20 laps. So once again, you're going to use this as a division problem. And we can see that you can't pull any 20s out of 16. So I'm going to add my decimal here. I'm going to bring it straight up and I'm going to add a 0. And I know that I can pull 8 20s out of 160. So what that tells me is that each lap was 0.8 of a minute. So then I would do the exact same thing with the first 4 laps. I would take 2.4 minutes divided by the 4 laps. I'm going to bring my decimal straight up right here. And 4 goes into 24 6 times. So in the first 4 laps, you were going at a rate of 0.6 minutes per lap. So you started out a lot faster than the entire thing. So these 2 ratios are not proportional. They are not proportional. So how long does it take you to swim 10 laps? Well, in this case, it kind of, it depends. If we use that first ratio for the entire 20 laps, your speed and rate is 0.8 minutes per lap. But if we use our proportion of the first 4 laps, it only took 0.6 of a minute per lap. So I can try it both ways. For 10 laps at this rate, we can see that it will take 8 minutes to do your 10 laps. But if we use the other ratio, we would take our 10 laps times our 0.6 of a minute. And this one shows us that it would only take 6 minutes to do the 10 laps. And the ratios kind of make sense because this one was your first 4 laps, and you can see that it was a faster time because you start out strong and then you get tired as you go. This ratio here, it is a slower because it shows the entire 20 laps, and as you slow down, you can tell. So as we are answering that question, how long does it take to swim 10 laps? In reality, it's going to be somewhere probably between these two, but we can get a good idea by looking at both of those ratios that are not a proportion. They are not equal to each other. So what you're going to be doing today, you're going to be doing some more problems online and checking yourself on those. If you have any questions on any of them, feel free to email me, and have a great day.